Our last video here is about the domain of a function in real life. This is coming from our lab manual. This is lab manual page 34 for this edition. But if we're looking at a real life context or a word problem, there are going to be some domain restrictions. So, and it says, many quantities in the real world cannot be taken on certain values. For example, time cannot be negative. We'll see a lot of examples like this. So you do need to think about, are there constraints to the real worldness of the problem? In number 7, we have the cost in dollars of producing X yards of a certain fabric is given by this function. So we have a function here, and let's just kind of recap what these variables are meaning. So X in this problem is the yards of fabric, and the output, C of X, is our cost. That's our cost in dollars. But so when we think about this function, the overall type of function that we're working with is cubic. So we see a cubic function because it's x cubed. And usually this has a domain of all real numbers. So usually negative infinity to infinity, but we do have to think about this in real world. So in real life, the domain is, so in real life the domain is, and this is what we're going to determine. Based off of our input, that's our yards of fabric, we want to think about, can we have negative infinity to positive infinity yards of fabric? No. We cannot have a negative amount of fabric. We can have 0 yards of fabric, or 1 yard, 2 yard, 3 yard, anything above 0. So our domain is bracket 0 to infinity. We just can't have negative, so we want to think about this in realistic terms. 8 has the surface area S of a sphere is a function of its radius, given by this function here. So again, we have a quadratic that is usually negative infinity to infinity. However, we're thinking realistically. What does this mean? So our input was R, which was the radius. Here's our independent variable. The output is S of R, which was our surface area. So realistically, when I look at our input of radius, can we have a radius that's negative something? No. There's no way that we're going to create a sphere with a negative 10 radius. But then we look at what possible radiuses could we have. Can I have a 0 radius? Well, yeah, technically yes, which would have an output of 0 because there would be no surface area. So our domain would be bracket 0 all the way to infinity, because I could have any positive radius and so on. Now 9, we have the stopping distance of a car. It varies directly as the square of the speed, but it creates this equation. What we're going to see here is this k value. K is not directly expressed in this problem, but we saw what D and S stand for. K is just a constant. Now, in terms of math and science, what we usually mean by that constant is just a number, just an arbitrary number that's being solved for. So arbitrary number right now that stays the same. So it could be something like 5. It could be something like 9.8. Just depends on whatever the actual k value is, but it's not affecting the domain of this function. The input S is what affects the domain. So our independent variable is S, which was speed. And we want to look at what's the domain. Realistically, that's a quadratic that would have been negative infinity to positive infinity. But realistically, the speed cannot be negative. We can't be driving negative 50 miles per hour. but we can drive 0 miles per hour. If our speed is 0, then we're not going anywhere and our stopping distance is 0. So the domain of our function would be 0 to infinity. Our dependent variables, what's the output in our case is d, which was our stopping distance. So when we think about a word problem, you will need to think about the restrictions of the real life part of it and how that's going to affect the domain. And it may not ask explicitly what is the domain of the function in real life. If it's already asking this about a word problem, it's implied. We're talking about the real life here. We don't want the domain of this function out of context. We want it in context. The last part of the lab manual, this will really kind of practice all those skills. So these are a little bit trickier and combining a bunch of different things. One thing I would note about 13 is, again, we're talking about a cube root. A cube root has no restrictions. However, a denominator does. So automatically that denominator has a restriction, but the cube root did not. So if we solve the denominator, the cube root of 2x plus 8 cannot equal 0. And you can solve that. You could cube both sides to get rid of this cube root. It would still be 0, and then you solve for x to find out your restriction. The numerator did not have any restrictions because there's no square root in the numerator. All right, so there's more for you to practice.